Okay, good morning all of you. Today we will see about importance of the salvage. A very nice concept. Already we seen some important information regarding Daniel cell and what are the electrode potential and what are the EMF of the cell, what is the standard electrode potential, standard EMF of the cell. We discussed everything. Today we will discuss about importance of the salvage. What are the importance of the salvage in the Daniel cell? First of all, it is helpful to internal connection completion. It is used for internal connection. Internal connection in the cell, and it is useful to increase the efficiency of the cell. Efficiency of cell. What is the meaning of efficiency of the cell? Power generation from the cell will be increased by using salvage. And one more important thing, it is useful to maintain the neutrality. Maintain a neutrality in the cell. Maintain a neutrality in the cell. Yes. What are the three importance of by using salvage? Okay, it is used to complete the internal connection in the cell, and it is increases the efficiency of the cell, means power generation from the cell will be increased by using salvage, and it is useful to maintain the neutrality in the cell. So how it is helpful we will discuss. First case I am explaining, if there is no salt bridge, what is the problem? No salt bridge, then what is the problem? And after we have to discuss about importance of the salt bridge. Okay, first of all, we are taking one container. I am taking, observe very carefully, one big container I am taking. Okay, in this I am taking one zinc rod. I am taking zinc rod dipped in corresponding salt solution, nothing but which one? Zinc sulfate solution. The container is separated with one semi-permeable membrane. Did you got it in where? Surface chemistry under dialysis. Semi-permeable membrane you have to use to make the container into two compartments, and in another compartment you have to take the copper rod dipped in corresponding salt solution, nothing but copper sulfate solution. Is there any salt bridge? No. Almost we are taking directly contact of two solutions with each other. Then we have to connect them through externally through voltmeter to check the power supply, how much is coming. Okay, then what happening? Anybody? If you take like this without using the salt bridge, the power generation from this cell will be come down. Why? Because I will explain you see carefully. As the time is going on, at zinc rod what happening? Undergoing dissolving, means zinc rod means solid is decomposing like Zn+2 going in aqueous medium plus 2 electrons. So from zinc rod which particles is coming? Zn+2 plus electrons is coming. Okay, after passing electrons from zinc rod to copper rod, there what happening? Reduction is going on from the solution. Okay, already in the solution what will be there? Cu+2 is there, and also SO4 2 minus is there. The Cu+2 is going on to the copper rod and it's forming a new layer. Okay, going like this. But after some time, the power generation from the cell will be come down. Why? Because once you check it here. Also, as the time is going on, our working process of cell will be going on. Here, what happening? Zn+2 particle concentration will be increasing. Are you agreeing or no? Yes. Okay, then here, as the time is going on, concentration of the Cu+2 is decreasing. Indirectly, which particle is more here? Yes, SO4 2 minus particles is more. Then what happening? These Zn+2 particles is moving towards cathode. These SO4 2 minus particles is moving towards anode. Okay, then what happening? At anode side we are getting one positively charged layer we are getting because of Zn+2 particles. Is it clear? So from cathode layer what is coming towards anode? SO4 2 minus particles is coming. It carries which charge? Negatively charged. At the junction of two liquids, we have oppositely charged layers. We have, that is, oppositely charged layers means between them what happening? Potential will be develops. That is only we are calling as liquid junction potential. Liquid junction potential. The same thing we discussed in surface chemistry under the charge on the colloidal particle, that is specially calling as zeta potential. Okay, at the junction of two liquids we have two oppositely charged layers. Okay, automatically between them some potential will be developed at the junction of the two liquid. That's why we are calling as a liquid junction potential. Because of this one, the efficiency of the cell will be decreasing. How, sir? Okay, for example, if you take like this, the EMF of the cell is showing 5 volts, but actually it's not a original value. Because of this liquid junction, actually it should get more than this, but because of liquid junction potential it is coming less. Means actually it should be get more than which one? More than 6 volt. 6 volts has to be get, but not coming 6 volts. Because of liquid junction potential, some value will be decreasing. Why? Liquid junction potential, for example, here minus 1 volts. What you observe here? EMF of the cell and the liquid junction potential are having opposite signs. Okay, actually should get how much? 6 volts, but only coming is 5 volts. Means how much loss? 1 volt. Why? Because liquid junction potential. Why liquid junction potential is arising? We are not using a salt bridge. That's why to increase the efficiency of the cell, compulsory we have to use the salt bridge. Then how efficiency will be increasing, we can get it. All of you getting or not? Yes. Now I will explain by using salt bridge how efficiency will be increasing. So with salt bridge, how it is more effective and how it is helpful to us. Okay, first of all, we have to take the anode container. In the anode container, we are taking zinc rod in which one? Zinc sulfate solution. And we have to take another container. In the another container, we are taking copper rod dipped in corresponding salt solution, nothing but copper sulfate solution. Those two are externally connected with the voltmeter or bulb to copper wire, and internally they are connected together through which one? Salt bridge. What is the meaning of salt bridge? Salt bridge is the U-shaped glass tube. Just U-shaped glass tube. This U-shaped glass tube only we are calling as salt bridge. I told what chemicals we are using to fill them. Yes, we are using some chemicals to fill. This one is nothing but potassium chloride or potassium nitrate. And we can use NaCl or we can use ammonium nitrate. Why we have to use only these chemicals? Also I will explain. Which chemicals has to be used to fill the salt bridge? Either potassium chloride or potassium nitrate, sodium chloride or ammonium nitrate. We have to use only these chemicals to fill the U-shaped glass tube, nothing but salt bridge. Okay, because of this one, what happening? The power coming from the cell will be increasing. How? You know very well, here what happening, Zn plus 2 particle concentration will be going on increasing. I am writing that only. Zn plus 2 particle concentration keep on increasing, but here Cu plus 2 particle concentration will be decreasing. Indirectly is nothing but SO4 2 minus particles will be high. Concentration of SO2 minus particle will be high. Okay, if you are not using salt bridge, one problem is this one. Okay, even though you are taking in separate container, you are not using salt bridge. The efficiency of the cell will be decreasing. Why? If you can contact, this is the problem. Without contact, you are separating them, but you are not using salt bridge. What happens? See, here dissolving going on, keep on increasing. So after some time, what happening in this vessel? Zn plus 2 particle concentration will be more. Just like right here, see. Zn particles is becoming like Zn plus 2 electron oxidation, solid aqueous medium. After some time, in this vessel, Zn plus 2 particle is very high. Means products is more or reactants is more? Products is more. If products is more, what happen? The forward reaction speed will be come down. Means the dissolving process will be come down. If dissolving process will be come down, there is no production of electron. There is no production of electron. There is no power supply. Means efficiency will be decreasing. Same thing will be happening here also. What happening here? Cu plus 2 particle will receive electron is becoming like copper solid. It is aqueous medium. Yes, going on, going on, going on. After some time, what happening? Very lesser amount of Cu plus 2 particles go over there. That's why the reduction will be very less. Then pulling from the anode will be also less. Then there is no transfer of electron. There is no power generation from the cell. Then efficiency will be decreasing. It should not. For that purpose, we are using salt bridge. So after using salt bridge, I told very important point. It is helpful to maintain the neutrality in the cell. How? Yes, in this anode vessel, which particles is more among? Zn plus 2 particle. If they are same, the forward reaction will be decreasing, means oxidation decreasing, then production of electron will be decreasing, power generation will be decreasing. So what I should do? I should neutralize Zn plus 2 particle by using something. For example, I am using here KCl, I am using in this U-shaped tube. At the ends, we have to take a porous material like cotton or silica gel or aluminum. We can fill that one. Otherwise, the liquid will be directly fall down in the two containers. That's why we have to keep here some cotton material or porous material we have to keep. Okay, then what happening, anybody? Yes, very good. KCl is decomposing like K plus and Cl minus. Now what happening? Cl minus particles is going into the anode compartment. Then what happening? Whatever newly Zn plus 2 particle is producing, they will be combining with Cl minus 2 particle. Then amount of the products will be less. Means indirectly reactant will be more. If reactant is more, what happening? Forward reaction will be increasing. Means rate of oxidation will be increasing. Means rate of liberation of electron will be increasing. Then the cell will be working very effectively. Okay, at the same time, what happening here, which is more SO4 2 minus. SO4 2 minus particle has to be neutralized. To neutralize, which particle is required? K plus particle. Yes, from KCl, K plus particle will be coming into this one. Then K plus SO4 2 minus. We have to take 2 moles here. We are getting potassium sulfate. We are getting here. What happening? Zn plus 2 particle is combining with 2 Cl minus. We are getting ZnCl2. We are getting. Like that, whatever particles will be excess in anode and cathode vessel, they are neutralized by taking chemical in the U-shaped vessel is nothing but a salt bridge. Sir, why you have to use only KCl or Chem? Only these 4 chemicals. What are the main thing here? One thing observe here, velocity of anion. Velocity of anion is equals to velocity of cation. What is the meaning of velocity? Means with how much fast Cl minus will enter into anode vessel, with the same speed K plus particle will also enter into cathode vessel. What happening? At a time, both the components will going neutralize equally. Then there is no problem. Otherwise, one is going slowly, one is going fast. Means what happening? Some imbalance will be appears. That's why if you take these 4 chemicals, in those 4 chemicals, cation speed is equals to anion speed. At the same time, they are going into two containers. Then maintaining neutrality will be long time. That's why the efficiency of this cell will be going on increasing. All of you getting or no? Yes. Now, all of you got clarity? Yes. This is the main point why we are using only this chemicals. Means velocity of K plus particle. Sorry, Cl minus is equals to velocity of K plus particle. Like that, all cations and anions in every chemical will having same speed. At the same time, they are going into opposite compartment. All of you clear? Yes. Now, I will explain one important thing. Very important thing. You have to observe very carefully. Standard hydrogen electrode. This is important for board examination for 5 marks. Standard hydrogen electrode. Standard hydrogen electrode. We can shortcutly calling as Sheath. Is calling as SHE, Sheath. And also calling as normal hydrogen electrode. Normal hydrogen electrode. He is also calling as NHE. She or NHE, both are same meaning. Nothing is here. And what is the use of this one and why you have to learn about this one? This She or NHE, standard hydrogen electrode or normal hydrogen electrode, is acting as a reference electrode. Reference electrode for calculating electrode potentials of different metals. Okay, so yesterday we seen standard electrode potential of zinc is minus 0.76, copper is plus 0.3. How they calculated? How they are telling those values? These all values they are explaining by taking She as a reference. Is one of the one device or one special equipment it is. It is a reference electrode for calculating the electrode potentials of different metals. First of all, we have to learn construction of She. How you will construct She? As a She has generally in chemistry She has very importance. Without She in chemistry as well as in our daily life we can't do anything. Yes or no? Yes or no? And at the same time the She is most dangerous. I will explain in chemistry as well as in daily life also. I will explain. You see carefully. She. First of all, how you will construct this one? First of all, we have to take a long platinum wire we have to take. At the bottom we have a plate or foil. This is totally made up of platinum. Why you have to use only platinum? Why not iron? Yes, nickel, palladium, platinum, these almost inert metals. They won't respond to any chemical reaction at ordinary condition. At some extraordinary condition they may, but commonly they won't participate in the reaction. First of all, you have to take the platinum wire with foil. And after that, we have to cover this one with glass tube like this. This is nothing but glass tube will be covered the whole platinum wire and foil. At the top, it has one inlet. For what purpose? To introduce hydrogen gas. Are you clear? And this is used for external connection in the cell construction. Okay, some conditions will be there. The hydrogen gas has to be sent at standard pressure, 1 bar pressure. Why? You are learning about the standard hydrogen electrode. That's why you have to maintain things will be standard. What are the temperature has to be maintained? 298 kelvins, because 25 degrees Celsius temperature nothing but 298 kelvins temperature. It will be taken in another container. You have to take another container. In this another container, you have to take one standard solution has to be taken. Do you know what is the standard solution? 1 molar HCl solution has to be taken. This is calling as a She, standard hydrogen electrode. Very simple, but the things should be maintained standard things. You have to introduce the hydrogen gas at 1 bar pressure and 298 Kelvin temperature, and whatever acid you are taking here, it should be 1 molar HCl solution. If you take like this, it is automatically acting as a standard hydrogen electrode. But what happening inside it? Why we are taking this one as a reference? I will explain. So first of all, what you are introducing? Hydrogen gas you are introducing. That only write out. Hydrogen gas you are introducing into this device. First of all, it will undergoing oxidation. Oxidation is what? It becomes like 2 H plus particles plus 2 electrons. This H plus particle will stay in air or solution. This H plus particle will stay in air or in solution. Goes into the solution. They are going into active speed. Going on. So after some time, what happening? Reversible process will be starts. Means the 2 H plus particle which are coming from hydrogen gas and already present in the 1 molar HCl solution. Those H plus particle will receive electron and recombine, gives H hydrogen gas. This process is calling as a reduction. Means in this She, what happening? Electrode is involving in the both oxidation process and also reduction process. Where oxidation will be going on, that part is calling as anode or cathode. Anode. Where reduction will be going on, that is calling as cathode. That's why this hydrogen electrode we are calling specially as reversible electrode. Reversible electrode. Why? Because in presence of same electrode, both oxidation will be going on, reduction will be going on. This is acting as a both anode as well as cathode. So we are specially calling as reversible electrode. Okay. Next, some other points we have to discuss. This is happening. So initially we are sending hydrogen gas, it will be undergoing dissolving into the HCl. Again those H plus particle will receive the electron and becoming like hydrogen gas. Okay, both oxidation and reduction will be going on. At a particular stage, rate of oxidation is equal to rate of reduction. How can you detect? Then we will call this device as sheath. Till then we can't use as a sheath. When rate of oxidation is equal to reduction, how can you predict or how can you identify the reduction is equal to oxidation speed? So whenever these two processes are going with equal speed, then we can absorb the hydrogen gas bubbles on the surface of the platinum foil. Then it will start sticking on the platinum foil. Then we can understand equilibrium is established in the vessel or device. Then only we are calling the total equipment as sheath. Then we can take its standard condition, standard electrode potential of hydrogen electrode should be taken as 0 volts, low value. But actually it's not meaningful. Means it never electrode potential should be 0. But for our convenience, whatever voltage will be coming in this device, that should be taken as 0. Why? Because we are using this one as the reference. Standard hydrogen electrode potential value will be 0 volts. How can you show this whole reaction? Can I write here? What is this one? Platinum. Is in which phase? Solid phase. Okay, solid physical state variation can be represented by a vertical line. And what is the reactant here? Hydrogen in bracket write down gas at what condition? 1 bar pressure, and it will be converting into which particle? H plus particle. Can we write as H plus? Is it which medium? Aqueous medium. At what concentration? 1 molar concentration. This is the representation. Sometimes he asks, how can you represent the standard hydrogen electrode? Platinum, let it be electrode. Reactant is hydrogen gas at 1 bar pressure. Product is H plus particles at aqueous medium at 1 molar concentration. This is the representation of standard hydrogen electrode. I think all of you got it. Standard hydrogen electrode is a reference electrode. Its electrode potential value should be taken as 0, but not actually equals to 0. We are taking for our convenience as the 0. Why? Because we are using for further calculation this one as a reference electrode. Okay, just I told now, it is a very important and it has dual nature. Dual nature means what? Based on approaching one, it can change its plate. Understood? Now I will explain. You see, how can you find out the electrode potential? Means the things will not be fixed. Based on approaching one, it can change his mindset. Okay, what is that one? Sheath. Means chemistry sheath. You see that one. For example, I want to find out the standard electrode potential of copper. How they told plus 0.34 volts by using SHE only. I will explain that when you see. Okay, first of all, I am taking sheath at one vessel, and it will be connected through copper wire through voltmeter. Then it will be connected to the zinc vessel. Zinc rod should be taken in zinc sulfate solution. How they predicted this value, you see carefully. We have full clarity regarding standard hydrogen electrode potential value will be 0 volts. Okay, compare with standard hydrogen electrode, whatever zinc will be there, is it more favorable for oxidation or reduction? Sorry, we are discussing about copper, no? Yes, sorry, copper sulfate you take. Okay, copper is more favorable for oxidation and reduction. I told already in the electrode potential concept. It is more favorable for the reduction. Means here Cu plus 2 particle will receive electron is becoming like Cu. So where reduction will be going on, that will be called as cathode or anode. Where oxidation will be going on, anode. Where reduction will be going on, that compartment, the total equipment is calling as a cathode. That's why you will call copper container as a cathode. Automatically she is acting like anode. Okay, you given connection, automatically what happening? Your oxidation will be going on, your reduction will be going on. After that what happening? Power transformation will be going on, then it will show some deflection here, some value it will be showing. That value only we are calling as EMF of the cell. What is the meaning of that one? Standard EMF of the cell is equals to formula. standard electrode potential of cathode minus standard electrode potential of anode. Those electrode potentials should be taken reduction potential values. Oxidation reduction is before two formulas is there, let it be. Okay, what is the standard electrode potential of cathode copper? You know? Don't know. You have to calculate it. Standard electrode potential of cathode, you have to calculate. That is nothing but copper. Anode value 0. So then we are getting standard EMF of this cell is equals to standard electrode potential of copper is nothing but standard EMF of this cell. Standard EMF of this cell means what value is showing here. That is only nothing but how much? Plus 0.34 volts. You got my point? Yes. Same like, can we calculate the standard electrode potential of zinc? Yes, I am explaining that only. Standard electrode potential of zinc by using Sheath as the reference. So first of all, I am taking zinc rod dipped in zinc sulfate solution. Zinc rod dipped in zinc sulfate solution. Okay, that should be taken at what concentration? 1 mole concentration, because we have to take standard conditions. That will be connected to sheath through which one? Cultivator sheath. Okay, this also should be taken as 1 molar copper sulfate solution. Okay, then we have to see what happening here. So see carefully, a standard hydrogen electrode potential value will be 0. We know very well, already just now we got it. Okay, zinc is more favorable for oxidation or reduction? Oxidation. That's why what happening here, zinc will be converting into Zn plus 2 electron solid going into aqueous medium. Anyway, the whole phenomena is calling as a oxidation. Where oxidation will be going on, that should be considered as anode. Automatically another electrode should be acting as cathode. Is it clear? Okay, now I want to find out the standard EMF of this cell for this device. What has to be done? Standard electrode potential of cathode minus anode. Standard electrode potential of cathode minus anode. Okay, standard EMF of this cell is equals to standard electrode potential of cathode means Sheath 0 minus. Okay, standard electrode potential of anode means zinc. Okay, already this value will be showing in this voltmeter. That is only nothing but standard EMF of this cell. That value will come how much you can see. Okay, if you can simplify here, what is coming? E naught of zinc is equals to minus T naught cell. That value showing how much? It is nothing but minus 0.76 volts. So standard electrode potential of zinc value will be like this. Like that, they are giving some standard values of different metals in a tabular column in your textbook. You can see whatever important I will explain maximum, and remaining if you have any interest you go through that one. Why I told she has dual nature means once you come to this point, when it will be connected with copper, it is acting as a anode. When it will be connected with which one? Zinc, it is acting as a. That's why based on approaching connection or based on giving connection, the sheath changing its nature or behavior as well as means either anode or cathode. But its electrode potential value will be always 0. Without sheath there is no electrochemistry. Without sheath there is no. It is no. Our yes or no? Yes, she has lot of importance, but finally her value will be. Don't tell like that. See, one class is completely required for competitive information. Based on this one, I will tell some competitive information. You see carefully. First of all, I am explaining something regarding delta G. These all are only for competitive point of view. What is the delta G? Change in Gibbs free energy for a reaction. Whether it is oxidation or reduction is not a matter. Okay, first point I am explaining related to this one. It is nothing but you take one reaction M means metal is undergoing oxidation, then it is becoming like M plus 1 electron. For this change in Gibbs free energy delta G is equals to some X value. How can you get it? delta G is equals to minus NFE. E means electrode potential. From that, if you can substitute, we are getting delta G is equals to some X value we will get. What I am doing, I am making reverse.